we want to find the absolute maximum and absolute minimum values of this function on the interval -1 to 4. So again, what we're doing is we want to find the absolute maximum and minimum values. Okay, so what we have to do is find the critical numbers, evaluate the function at the critical numbers, and then also evaluate the function at the endpoints. So let's find the critical numbers. Now remember, critical numbers are where the derivative is 0 or where the derivative is not defined. So that's what we're looking for right now. So we'll first find the derivative using the power rule. So f prime of t equals 1 minus 1/3 t to the -2/3. So that's the derivative. But what we need to do is simplify. So we will simplify. Again, f prime of t is 1 minus 1/3 t to the -2/3. So what I want to do is rewrite this as a single fraction, and that would end up being 3t to the 2/3 minus 1 all over 3t to the 2/3. So you can double check. If you split up this fraction, you'll get back the previous expression. So this is an equivalent expression for the derivative, and it's actually more convenient for us because now we can easily identify the critical numbers. So notice that at t is equal to 0, the derivative is not defined. And if you set the numerator equal to 0, so we have to now solve 3t to the 2/3 minus 1 equals 0, we get t equals the square root of 3 over 9. So what that tells us is that f prime of the square root of 3 over 9 is equal to 0. So the critical numbers are t is equal to 0 and t is equal to the square root of 3 over 9. So remember, our original function is f of t equals t minus the cube root of t, and the interval was -1 to 4. So what we're going to do now is this: we're going to evaluate f of t at the endpoints and also the critical numbers. So f of negative 1. If we plug in t is equal to negative 1 into the function, we actually get 0. Remember that one of our critical numbers was t is equal to 0. And if we plug in t is equal to 0 into the function, you get 0. And the other critical number was, t is equal to the square root of 3 over 9. So plugging in t is equal to the square root of 9 into our function, we get the square root of 3 over 9 minus the square root of 3 over 9 to the 1/3. And this actually ends up being approximately negative 0.385. Because remember, we have to compare all of these y values. The largest is the absolute maximum, and the smallest is the absolute minimum. So if I plug in the other endpoint, the right endpoint, t is equal to 4. T of 4 is 4 minus 4 to the 1/3, which ends up being about 2.41. So looking at all of these y values, we see that the absolute minimum would have to be f of the square root of 3 over 9, which is about negative 0.385. And notice that 2.41 is the largest y value that is of these 4 values. So the absolute maximum is actually f of 4.